Okay, in this section, we're going to talk about how to find the rational equation when you're given the graph. So to do that, we need to work backwards. So we are finding 1, 2, 3, 4, 5, 4 points from the last video, which is the intercept, vertical asymptote, horizontal asymptote, or slant asymptote, or removable discontinuity. This time is the opposite. We look at the graph and find all of these 4 and try to help us to find the graph from the equation. So the equation should be in the form of with the coefficient a, and then on the top should be a minus x minus b, s minus c would be your factor, and x minus maybe e, I don't know how many, with some power. Can be 1, 2, 3, 4, 5, 6, 7. So that's why I use P1, P2, P3. And in the bottom, we have a different factor, such as x minus m, and then you have a different multiplicity for the vertical asymptotes. So you just walk like this way. Okay. So here is the equation. Here is the graph. I want you to find the equation for me. Here is a -1, and this is -2. And they have a y-intercept in here at -2, another vertical asymptote at -2, and then an x-axis at s-intercept, at 3. This is positive 2. Sorry. Oh, my brain doesn't work. Okay, so here we got -2. This is -2, -1, -2 on the y-axis, and this is 2, and this is 3. Okay, based on this graph, we need to find the equation. Now, let's label what do we have. We know that you have a 2x-intercept. Remember that how do we find x-intercept is the numerator. So that means the one factor we have is x plus 2 times x plus 3. And if you look at the behavior, this behavior, x-intercept behavior, is a cross. And this is another x-intercept. The behavior is a cross. So that means we expected the multiplicity is either 1, 3, or 5, all the odd numbers. So I usually keep it as simple as possible, so I keep it as 1, so that my number will be smaller. Okay, so the denominator, it will be determined by the vertical asymptotes. So we have 2 vertical asymptotes. One is x equals to -1, the other one is x equals to +2. So this to give us a x plus 1 and then x minus 2 for these 2 asymptotes. And the next thing is we need to look at the behavior. So the behavior for this one is the direction about this graph is one goes up, the other goes down, so it's opposite. So that means the multiplicity is going to be 1, 3, 5, 7. So I keep it 1. And then the second vertical asymptote, the behavior, they both goes down. So that means they are going to the same direction, or they are adjacent to each other. So that means this is going to be a even number for the multiplicity. It can be 2, 4, 6, 8, 12, 20, whatever that you like to do. And then we need to put the a down. So this is the scratch of the rational function. And how do we determine by the a? We use the y-intercept. Because y-intercept, we have 0, 0 and -2. So let's substitute 0 and -2 for x and y respectively, and let's find our a. So I have -2 equals a times 0 plus 2 times 0 plus 3 over 0 plus 1 times 0 minus 2 squared. Don't forget the square because the behavior here goes to the same direction. Okay, simplify it. We have a times 6 over 4. Simplify it. We have 3a over 2 is equal to -2. So that means our a is equals to 4, 3. Did I miss anything? Oh, I missed one thing. I make a mistake. These 3 should be a minus. Minus, because we have x-intercept is a positive number, so that means the factor has to be x minus 3. Always check. I know something is off. So this would be negative. So now this is negative, so our a is 4 over 3. So that means our rational function would be 4 over 3 times x plus 2 times x minus 3 over x plus 1 times s minus 2. Again, always check this with a decimals. See if this matched the graph that was given. Okay, let's take a look. Y equals to 4 times x plus 2 times x minus 3 over 3 times x plus 1 times x minus 2 square. Yep, that's the graph that we have, and it matches all the points that we got. This point, and this point. So we're good to go. Oh, one more thing we need to check is the removable continuity, because the graph didn't show us any removable continuity, so that means this is good. Okay, that's it. See you in the next video.